Today we are going to solve this problem from JEE Advanced 2024. This is an interesting problem and you must attempt this problem one time before watching the solution. So let's start solving this problem. So here what we need to actually do, we actually need to find the value of k from this equation which includes limit also, right? So let's start solving it. So what is given? Limit x tending to 0 positive, okay, sine of sin kx plus cos x plus x to the power 2 by x equal to e to the power 6. First, what we will check? We will check which indeterminate form this is making. Okay. So to check it, what we will do? We will put x equal to 0 simply. Okay. So if we do it, then kx will also be equal to 0. So sine 0 is equal to 0. And here we are getting sine 0 again. So sine 0 is also equal to 0. So this term will be equal to 0. Now cos 0 is equal to 1. So this term will be equal to 1. And we are putting x equal to 0. So this is equal to 0. So here it is going to be equal to 1 if we put x equal to 0. Now let's check the power. If we put x equal to 0, then we will get 2 by 0, which is approaching to infinity, right? So this is actually making 1 to the power infinity indeterminate form. Clear? So now we know a special formula for this type of forms, which is if there is something like limit x tending to a fx to the power gx, right? Then and if fa is tending to 1 and ga is tending to infinity, okay, that means it is making 1 to the power infinity form. Then we can say that this limit is equal to e to the power limit x tending to a gx into fx minus 1. So this is the formula. So we will apply this here. So if we apply that here, it will be e to the power limit x tending to 0 positive 2 by x, okay, 2 by x into sine of sin kx plus cos x plus x minus 1, okay, equal to e to the power 6. Now you can see that the bases are same, both are e, and so the power will also be equal. So we can say that limit x tending to 0 positive. Now we will open the bracket. So here it will be 2 sine of sin kx plus 2 cos x plus 2x minus 2 upon x equal to 6, right? So now let's check which indeterminate form this limit is making, this one. So to check it, we will put x equal to 0 again. If we put it, then kx will also be equal to 0. So this term, 2 sine of sin kx will be equal to 0. Okay. Because sine of sin kx is equal to 0. Okay. And here cos 0 will be equal to 1. So this term will be equal to 2. 2x will be equal to 0. And here it is minus 2. So 2 and minus 2 will be cancelled out. So in the numerator it will be equal to 0. And in the denominator, if we put x equal to 0, here it will be 0. So this is making actually 0 by 0 indeterminate form. So for this, what we can do? We can apply L'Hopital rule. Okay, we can apply L'Hopital rule. So if we try to do it, it will be, this will be limit x tending to 0 positive. Okay, x tending to 0 positive. Now the derivative of the numerator with respect to x is 2 cos sin kx, okay, into cos kx into k, okay, according to the chain rule, minus 2 sin x plus 2. Okay. And the denominator here it is x. So derivative of x with respect to x is equal to 1. That is simple. So this is equal to 6. Right? Now we have to solve it. If we put x equal to 0 here, you will simply get that sine kx will be equal to 0. So cos 0 is equal to 1. So here it will be 2 into, now kx is equal to 0. So cos 0 is equal to 1. Okay. So here it will be 2k minus, here sine 0 will be equal to 0. So this term will be equal to 0. So here it will be plus 2 equal to 6. Clear? So we got a simple equation. Okay. So from here, if we solve for x, we will get 2k equal to 4. So at the final, we will get k is equal to 2. So that is our desired answer. So what is the correct option? Option B is the correct option. So this was a simple question, I guess. Okay, this was a simple question, not so hard. The main thing is this one. Okay. So if you like this video, make sure to like, comment, and share, and subscribe to our channel for more amazing tools and concepts. Thank you for watching the video.